Alright, Mr. Trutna, this is Math 2, Unit 4, Worksheet 3. This is the assignment that was given to you last Friday, so let's go ahead and let's just rock and roll and get this thing going here. So number 1, we did numbers 1 to 13, so we did every problem on the first page, then we just did a couple problems on the other side. So number 1, we're going to draw the angle bisector of angle A. We're going to mark the diagram showing congruent angles. Okay, so we're going to draw the angle bisector. Remember, a bisector of an angle, aka also known as an angle bisector, will take an angle and it will split it into two smaller equal angles. So I need to draw a line segment that's going to split angle A here into two smaller equal angles. Maybe something like that, and you could make that line segment that we draw as long as you want. You could literally stop it right there. You could keep it going all the way outside the triangle. It doesn't matter. Okay, and then we need to mark the diagram to show that these two smaller angles are equal. And the way we do that is we put those marks. There we go. There's the angle bisector of angle A. Number 2, draw the perpendicular bisector of side DF. Okay, so here is side DF right here. And what we're going to do is we are going to bisect side DF, and then we're going to make it perpendicular. So we're going to draw a line segment that goes right through the middle of DF. So let's make a point. Let's make a point right in the middle. Let's make the congruent marks right here to show that's in the middle. And then we're going to draw. We're going to use my ruler, and we're going to draw a line segment that goes right through that middle, but it's going to be perpendicular, which means it has to make 90 degrees. So something like that would work, okay, and mark the 90 degrees. Notice part B says, mark your diagrams showing right angles. I did that. And congruent segments, that's what those tick marks show me. Okay, number 3, if a point is on the, and this would be the bisector of an angle, I gave you this answer in class actually, then the point is equidistant from the side of the angle. Okay, so what that means is we could use that to solve for x in number 4 and number 5, where it says find the value of x. So notice we have this line segment going right here. Okay, and notice that that line segment created a 38-degree angle and a 38-degree angle. So that line segment is an angle bisector. So then this statement is saying if we put a point on that bisector, then it is the same distance, it is equidistant from the side of the angle. So in other words, that distance from the point to the side of the angle and that distance, those are the same. So if I wanted to solve for x in number 4, I would write the 3x side is equal to the 12 side, and then I would divide both sides by 3. X is equal to 4 for number 4. We're going to do the same idea for number 5, but we're going to think of it backwards. So if you notice in number 5, we are told that that distance is 5. We're told that distance is 5. So what does that mean if this point right here is the same distance to both sides? Well, it means that these two angles have to be the same. It's saying that this line segment right here, which actually is a ray, not a line segment, okay, but it is an angle bisector. So if I wanted to solve for x, I would take that angle's value, 4x, I would set it equal to that angle's value, 2x plus 20, and then I would use that information to solve for x. Subtract 2x's from both sides. That would give me the equation, 2x is equal to 20. Divide both sides of the equation by 2. X is equal to 10. So that's how we would do number 5. Okay, moving on to number 6 through 7. It says find the indicated values of the variables and the measures. So we're going to use the concept of number 6, the same concept we used in number 4. Okay, and what we're going to do is we're going to notice that, well, we have two equal angles. So that means that line segment right there is an angle bisector. So that means A to B, which is 5x minus 3, is going to be the same distance or equal to A to C, which is 3x plus 1. So to solve for x, I use the equation 5x minus 3 equals 3x plus 1, And now I'm going to solve this. So I'm going to subtract 3 x's from both sides of the equation. I'm solving for x. The 3 x's would cancel. My new equation would be 2x minus 3 is equal to positive 1. I'm going to add 3 to both sides of the equation. The 3's would cancel. My new equation would be 2x is equal to 4. I would divide both sides by 2, so I get x is equal to 2. Okay, so that'd be the first part. The second part now wants to know b to a. In other words, how long is it from b to a? All right, well, how do I do that? Well, if you notice, b to a is represented by the expression 5 times x minus 3. We just found out that x was 2, so I'm going to substitute a 2 in for x, so I get 5 times 2, 10 minus 3, so b to a is equal to 7. Okay, now d to a, if I'm really thinking, if you notice, d to a, we already said that it's equal to b to a, so I really don't even have to do any work if I wanted to. I know that d to a has to be 7 as well. They're the same distance. But let's try it out, just check. Okay, I don't trust myself. d to a is represented by 3 times x plus 1. X is 2, and if you notice, 3 times 2 is 6. 6 plus 1 is 7. So it is 7. I should have just trusted myself. Number 7, we're going to find the value of x. We're going to use this diagram here. Then we're going to find angle BAC, and then we're going to find angle DAC. So first of all, let's find x. Okay, so what do we notice right here? Well, we notice that we've got these 2 equal angle marks. So that tells me that angle, so that angle right there is angle BAC. It is the same as, or it's congruent to this angle down here, which would be angle DAC. So we know that these 2 angles are congruent, which, by the way, will help me when I have to find these values. Once I find one, I know the other. Well, angle BAC is represented by 3x plus 12. Substitute that in. Angle DAC is represented by 5x. Substitute that in. And then we solve for x. So I'm going to subtract 3 x's from both sides. That would give me the equation of 12 is equal to 2x. I would divide both sides by 2. X is equal to 6. Okay, now to find the measure of angle BAC, notice BAC is represented by the expression 3x plus 12. So if I take 3x plus 12, that's an x. I substitute 6 in the place of x. 3 times 12 is 18. 18 plus 12 is 30. So both of these angles are going to be 30 degrees. All right. Okay, moving on. Number 8 through 13. We're going to use the figure at right here. So we're going to use this figure to answer the following questions. Number 8. How far is M from KL? Well, here's M. Here's KL. How far is it? Well, you can see right here. It is 8. The answer number 8 is 8. Number 9, how far is M from JK? So here's M. Here's line or ray JK. All right. So how far is it? Well, it's this far, which is the same as that, 8. So the answer to number 9 is also 8. Number 10, how is line K to M, how is that line related to angle JKL? Here is JKL. Well, how do we know it? Well, look, if M is the same distance from this big angle here, that means KM is an angle bisector. Those 2 angles would have to be the same. So KM, how is it related to angle JKL? It is an angle bisector. That means that it split the big angle JKL into 2 equal smaller angles. Okay, number 11, find the value of x. How am I going to find the value of x? I'm going to take the 3x angle and make it equal to the 54 degree angle because they are the same. Divide both sides by 3. X is equal to 18. Alright, now that we know the x is 18, number 12 wants us to find angle MKJ. So angle MKJ, let's find out where that is. There's M. Follow it down to K, take a turn for J. Whoop, J, I went to L, so M to K to J. It's that angle right there. So notice MKJ is represented by 3x. X is 18. 3 times 18 is 54. And I really didn't even have to do that in number 12. I could have noticed that angle is 54, and they're equal. So that one had to be 54. Number 13, find angle JMK. So JMK, that would be that angle right there. And angle LMK, L up to M, take the turn, it'd be that angle right there. So I want to find those angles, and they're going to be the same. Well, how do I do that? Well, let's focus in on this triangle right here. Alrighty. Well, that's 90. That angle's 54, and I want to find that angle there. So I'm going to take 90, I'm going to add it to 54. That's 144. And then I'm going to take away 144 from 180, because the three angles in a triangle are 180. So that gives me 36. So that is angle LMK is 36 degrees. Okay, so that angle is 36 degrees. Well, how many degrees does that angle have to be? Well, it has to be the same. These two triangles are the exact same triangles. They're congruent. So that angle is 36 degrees as well for angle JMK. There we go. Okay, turning it over to the other side. On the back side, the only problem I wanted you to do was number 15A and number 16A. So if you notice in number 15 and 16, it says use the figure on the right to answer the questions. Okay, so 15A, the point of concurrency. Where's the point of concurrency? So remember, the point of concurrency is where three or more lines intersect. That would be right there. Okay, so it wants to know, is that an incenter, or is that point called a circumcenter? Well, which one is it? All right, well, what we do is we look at the picture and we see, what did I get? Well, I had that line segment, which if you notice is perpendicular and a bisector. And if you notice, all three of these line segments that meet are all perpendicular and they're all bisectors. Okay, so what's the point called where the three perpendicular bisectors intersect? Circumcenter. So number 15A, you should have chosen circumcenter. Okay, number 16A, same idea. We're using this diagram down here. Okay, and we want to know the point of concurrency is called what? Well, is it an incenter? Is it a circumcenter? Well, there's the point of concurrency right there. And what intersected there? Well, we had that, and that all intersected. What are those? Well, notice we have equal angles. We have equal angles. We have equal angles. So these were all angle bisectors. So that would be an incenter. The incenter is the point of concurrency where the angle bisectors intersect. Have a great day, evening, morning, whenever you watch this video. Smash the like button. Come on, I got to make some money. Adios.